Hello and welcome to the Qubit Guy podcast, brought to you by Classiq, the quantum algorithm design company. My name is Yuval, and my guest today is Rene Schulte, Research Director at Valorem Reply. Amongst other topics, Rene described several customers that are taking quantum computing solutions into production environments. These are customers in energy, transportation, and telecommunication verticals. We hope you enjoyed this episode. Please let us know how we did by emailing hello@classiq.io. That's hello@classiq.io. Hello, Rene, and thanks for joining me today.
Hi, Yuval. Thanks for having me. It's fantastic to be here.
That's wonderful. So who are you and what do you do?
Yeah. Well, first of all, my name is Rene Schulte. My role is Director of Global Innovation at a company called Valorem Reply. And what I do there is basically research and development around emerging technology with a focus on, typically I say, like three key areas. And the first one being spatial computing, things like, mixed reality, augmented virtual reality, but also things like 3D sensors, LiDAR, and that kind of stuff, like all things that are related to spatial computing and spatially understanding the world around us. That also comes with the second, which is computer vision, AI, that kind of stuff. And also robotics and, last but not least, of course, quantum computing. And I've been working in that field since like 2 or 3 years on, the applied quantum computing, I would say, and the impact we can achieve already today. That is the main focus. Less on the scientific research, but more on what can we do already? How can we use applied quantum computing to provide benefit to our clients? I'm also a Microsoft Regional Director and MVP. These are awards that Microsoft provides to, like they say, community leaders that share the knowledge. So I do a lot of conference talks, a lot of virtual conferences these days, but also one in person coming up this week, actually, which I'm super excited about. And also, on social media and, constantly sharing knowledge, basically. And so that is being honored with these awards. So doing a lot of things. I also have my own little quantum computing video series. So think about like a podcast, but you can actually see the people while they're talking, which I call Qbytes, not qubits, but Qbytes with another E. And so I call it Qbytes, bite-sized pieces of quantum computing. And so that's me. That's what I do. Basically always having my ear on the industry pulse in all of these areas, very technical, but also I understand the strategy and business all around. And I'm always passionate about all of these topics.
And in terms of geography, I think Reply is a global business, but do you focus primarily on Europe or in other areas?
Yeah, that's a good question. So, like I said, I work for Valorem Reply. Valorem Reply is a US company. I actually live in Germany, working for US companies since almost a decade now. But actually, Valorem Reply is part of the Reply Group, which is headquartered in Italy and has a strong presence in Europe, in Italy, in Germany, all over the place. But like I said, Reply really has offices all over the place in the US, in the UK, in Germany, in Italy, all over the place. And I work a lot together with my colleagues, for example, from Data Reply when it comes to quantum computing and the machine learning Reply, but also at Valorem Reply, we do a lot of interesting stuff in that space. Yeah.
Excellent.
And basically what we do is professional services, consulting in the end, but not just on a strategy level, but really we can start on a strategy, but then we also support the clients throughout the whole development as well. And so we sometimes do our own product development, but oftentimes it's custom development for clients. And it contains all different vendors. So it's not just Microsoft, but it's all of them are part of the basically what we develop with, and vendor independent, but also a lot of different technologies. Reply is around 10,000 people, split up into multiple sub companies, basically. But as you can imagine, just from the size, it's basically general professional services, all related to software, but also a little bit of hardware.
So when you focus on quantum clients, do you see that in a particular industry, a particular application? Is it pure quantum, or is it more of the quantum inspired optimizations and so on? Tell me a little bit about what you're seeing in the market in terms of where quantum is taking hold.
Absolutely. And so we don't see like a particular industry. Of course, there are certain industries that are well suited at the moment. I would say everything that has a strong nonlinear challenge, right? Which could be drug discovery, fertilizers, chemical processing in general. I mean, if we think about how chemistry actually really works, it's quantum chemistry, right? And so using quantum computing to actually be able to simulate how the chemistry, how our universe is really built is of course very beneficial. And there's a strong advantage in these industries, of course. But it's not just particular industries. We're working with automotive, we're working with telecommunications, with utilities sector, a bunch of our clients, and I can share some examples later of some of the projects we already executed and the things we see there. But first of all, I would say, like right now, we focus on three key areas. And the first one being quantum machine learning, which basically is analysis of classical data on quantum computers, right? And you can already achieve some really interesting things. And we are part of a bunch of projects and research there, which unfortunately I cannot mention because of NDA reasons. But with QML, with quantum machine learning, there's amazing stuff that can be done, for example, for image classification, right? And some of our experiments have shown that certain newer QML algorithms provide not just a faster result than classic machine learning, but actually are also more precise, which is crazy if you think about it. It's not just faster, but also more precise. But again, like if you think about how is our universe built on the smallest scale, it's all quantum mechanics, right? So, applying quantum machine learning maybe also gets closer to the real reality of our analog world, which is of course built on this principle of uncertainty, if you will, compared to this kind of digital world, which is just 0-1, right? So getting closer to the nature also helps us to simulate faster, but also better, which is interesting. So QML is one. Another one is, of course, quantum-inspired optimization, which we developed a certain solver, which is called QUBO, quadratic unconstrained binary optimization. And the idea behind general quantum-inspired computing, and in particular quantum-inspired optimization, is using principles of quantum computing and quantum algorithms, but not having them run on quantum computers, on real quantum computers, but having them execute on classical computers. But of course, very powerful ones, like think about GPU, like graphics card array, in where you can execute a lot of parallel operations, or FPGAs, or some of those, right, where you can really do some interesting workloads there. And so you can leverage quantum computing principles, implement these in algorithms, and then run them on these kind of classical hardware and achieve better optimization results and faster than classical algorithms, than classical optimization algorithms on classical hardware, right? And if you think about the future, like once we have enough powerful quantum computers available, well, these algorithms don't have to be rewritten, right? Because they are already built for quantum computers, but they will just fly if you basically execute them on a true quantum computer. And we can talk a little bit more about that later. Like I can share some use cases here where we're seeing really quite a great return of investment with quantum inspired optimization. But I just want to mention also the third key area, which we see is quantum security and quantum communication. All of that is related to the quantum security field, right? Which of course you have the two kind of I would say, like on one hand, quantum security is a threat, as we know, right? With Shor's algorithm, you can crack encryption like RSA, and once there's enough powerful machines available, once there are enough powerful quantum computers available, it is said that if you have 4,000 stable qubits, you can crack RSA 204080, right, which is the current standard for a lot of secure communication. Like the whole internet is built on secure communication these days, and so if you can crack those, well, then a lot of bad things will happen, of course, right? And this is going to happen in a few years for sure. You might have heard IBM announced that they are planning in 2 years, in 2023, to have a quantum computer with 1,000 qubits. Right, so it's getting closer, and with 1,000 qubits, you might be able to actually already crack like I don't know, I didn't do the math, but let's say RSA 2056 or so already, right? And so there's this big threat of, the so-called Q day is coming, or in relation to the millennial bug that you might know, it's also sometimes called Y2Q day. It will happen. And so what we provide as a service is, for example, consultation, but also advice for clients what they can do already today, because they don't have to wait until it's too late with the Q day, but they can already do certain things already today, right? So this is really interesting when it comes to quantum security, because it will happen. It's just a matter of time, but folks should prepare now. And so this is where we are putting a lot of focus. But also there's, with quantum security, there's also the quantum communication, like quantum key distribution, where you can securely exchange keys, symmetric keys and that stuff. So there's also opportunities with, also true random numbers and so on that you can generate with quantum computing. And all of these kind of free areas like quantum machine learning, quantum inspired optimization, quantum security, all where we see the biggest impact when we work with our clients, where there's, achievable impact already today. And even if the infancy of the quantum computing hardware, like especially quantum inspired computing, is running these algorithms faster than classical hardware, right? And that's I think really impressive that we can actually already achieve with the infancy of the hardware. We can use the principles to build software with quantum inspired computing that is outpacing classical optimization algorithms.
So given the infancy of the hardware, and given that there's a widespread interest in quantum computing, do you see the ROI today? Do you see companies actually moving quantum projects into production and getting real business value from it? Yeah. Or is it more on the exploratory side? Let me investigate this, let me investigate that, and maybe in a couple of years, we will move it into production?
Yeah. A lot of these projects, of course, and I would say a pilot phase, but one of our clients actually moved their quantum inspired solution into production already. I cannot mention the name here, but it's one of the largest energy grid providers in the world. And they basically maintain these energy grids, as you can imagine, like, landlines and transformation stations and whatnot, a lot of stuff. And they have like 20,000 field service workers, like 20,000 people that every day have a certain schedule where they need to, drive with the car or whatever way of transportation they use, but basically go to these certain stops. They need to perform an action, like, I don't know, repair a transformator or whatever it is, right? And so they have these 20,000 field service workers, which their schedule has to be planned in advance, of course. And so, as you probably know, being from the computer science, there's a classical NP complex problem, which is called the TSP, the traveling salesman problem, right? Or a scheduling optimization problem, right? So the more stops you add, the more exponential will grow, right? So the more complex it gets. Because what the optimization goal you want to achieve with that is, of course, you want to maximize the time that the field service worker spend working, but you want to minimize at the same time the time they spend on the road, like traveling, basically, right? So you want to find the optimal schedule. And long story short, for this client, we introduced our MegaQubo solution, this quadratic unconstrained binary optimization algorithm. And this can be used for this workforce management, right? And so in a few minutes, the optimization algorithm that we developed can identify a schedule that maximizes the amount of time spent working while minimizing the time spent on the road, right? What they achieve is pretty impressive. They achieve a 20% reduction of travel time for 20,000 field service workers, right? And this is an execution time speed up of 18 times on a GPU cluster, right? And so that is I think some pretty telling numbers. So this is a lot of time and money saved there. And this is done again with quantum inspired optimization with our MegaQubo solution, where you can put in certain things and then it gives you the optimal schedule as an output. And this is one example. And another few examples where we're working with clients is like a large telecom operator. Again, so the one I just mentioned, the case, this is deployed in production already, right? So this is running and it's optimizing the schedule and gives a lot of ROI, as if you can do the math yourself, like 20% reduction travel time for 20,000 field service worker. That's big money, of course, right? But we're also part in a bunch of challenges like the Airbus Quantum Computing Challenge. We took part in that, and a team of machine learning reply actually was winning that. So the machine learning reply folks won the Airbus Quantum Computing Challenge with a solution. Again, also an optimization solver, an optimizer, basically. Well, that optimize the loading of a plane. As you can imagine, that is a super complex problems with, I don't know, like hundreds of variables, maybe. Like, I don't know, like, you know, you have to center of the mass of the plane. You have all these physical constraints. You cannot go over a certain mass in total. You have to distribute the weight in a certain way. You want to minimize the fuel that has to be used. You want to minimize the time the plane is on the ground and all of that. So there's a bunch of things if you want to load a plane optimally that is very complex and challenging. And so we developed this solution and won the Airbus Quantum Computing Challenge, for example. Another example is for a telecom operator. We did a pilot project there where we were using, again, optimization solver, MegaCubo, to optimize the distribution of basically the frequency range, right? So as you can imagine, think about you know, a 5G network, like antenna, like a cell tower, if you will. And so, of course, this cell tower can only serve a certain amount of users, right? At some point, it's maxed out. And so you want to optimize. And so basically they have this range and they want to optimize. It's a little bit fragmented, right? And they want to optimize they want to have as many users as possible. And so you need to basically pack them in an optimal way. And this is also showing some really promising speed ups when it comes to using quantum inspired optimization for this, right?
So to grow your business, the quantum side of your business, obviously you want more customers to move into production and more customers to show positive ROI. Other than stronger computers, what do you think is missing? What is needed to accelerate that deployment of quantum solutions?
Yeah, well, you can split it in multiple areas, I would say. But if we're thinking about like from a technical standpoint, I think there is a need also to have this kind of how would I say, like this middle layer on also the programming language available that can be used not just with one particular quantum computer, because you need to imagine like these quantum computers are in a very early stage, of course, right? Think about the mainframe area in the last in the 20th century, of course, not in the 19th century, but in 20th century, in the middle of the 20th century, we had this mainframe area, right? And so this is probably comparable to the state of quantum computers today. Of course, it's not 100% comparable, but you get the idea, right? It's huge things, and they have all specific ways to program them, right? And so you actually have to talk to them, to these quantum computers, and program them with a machine language, or, well, it's not even comparable to assembler for classical computers, but really you need to, basically use a language that is not a high-level programming language. And also you're very much dependent on that certain quantum computer. And so the challenge for the development, I think, that is being solved at the moment with things like, for example, Q Sharp, for example, or although from IBM, they also have some stuff, and a couple of other companies, of course. But basically, you have a high-level programming language, which you can write your quantum algorithms in, and then you have a middle layer, basically an interpreter, or like for Q Sharp, it's the QIR, the quantum intermediate representation, which is a representation of your code that can then, with a machine-specific runtime, can run on any of those, right? So you basically have a high-level programming language. You have one language, and you can target, whatever kind of quantum computers out there, as long as each of them provides a runtime that can talk with your QIR, basically. And so, long story short, what I think is missing is, I think it's being solved, is this kind of generic and more approachable programming style and programming languages for quantum computers. But beside the technical things, of course, there's also in general, clients might be hesitant because they might still think, oh, yeah, I heard about quantum computing, but this is a thing that might be happening in 10 years or so. So we don't care about it at the moment, right? That's what you hear oftentimes. And that's why also with my Qbytes video series, I try to focus on the impact today, because there is already achievable ROI with certain solutions. And I think we need to show more cases where you can see the real benefit that can be achieved already today, right? But of course, we also need, more powerful quantum computing hardware. And another thing, which I'm also great that you, for example, you will have the podcast here, and I'm doing my video series, and I know there's a couple of other folks that also do podcasts or video series, is the education, right? And knowledge sharing in that space, and getting quantum computing out of the research world and out of this kind of a little bit exclusive club, if you will, to be more approachable for everyone, because you need not just folks that have a PhD in physics, but you also need people that understand program management or project management, and you need, of course, engineers, you need developers, you need marketing folks, you need all of this. What we know from classical computing is now needed, because we're getting out of the science and research stage and getting into real applied quantum computing, even in its infancy. So I think what we need is more folks joining the quantum computing bandwagon, if you will, that are not coming from the pure quantum information or quantum computing background from the university, but also more diverse background and a more inclusive community. And then we also need to show more ROI that can be achieved with these quantum solutions today. And like I said, of course, from a technical standpoint, which is already being solved with Q# and a few language other things, is this kind of not just targeting specific quantum computers, but having more of a generic programming language.
I was speaking with a partner from McKinsey the other day, and he mentioned a term that he called business translator. So someone who says, I can translate the technical benefits of quantum into a business benefit, into the ROI. This is not just what it does, but also why should you care, and how can we deliver value today, and which projects you'll have to wait a couple of years before you can see real value. I like that term, and I think it may be actually what your company does, amongst other things, is help communicate the business value to the customers.
Exactly. And actually executing those, right? We can communicate it, but we can also deliver. And that's important.
My last question, you mentioned that Reply is built out of several different companies, several different units. Do you see quantum projects as standalone projects, or do you see them integrated into a broader enterprise software or hardware architecture? Where's the data center? What's the SLA? How does data come in? How does data get out? Is it isolated or is it integrated?
Yeah, both, I would say. It really depends on the clients. Also, it depends, of course, from the business development standpoint, like what is the client relationship, right? Which folks are involved there. But from the typical thing, like the quantum projects themselves, there are typically specific things, because like you cannot just solve every problem with a quantum computer. That's also a misconception. A lot of folks I talk with, not the experts, of course, but a lot of like folks that are just hearing about quantum computing, there's a little bit of this kind of misconception that quantum computers will be these kind of generic computers, right? And while I'm holding up here my smartphone and showing that to you, that we will have a quantum computer running in our smartphone, right? Or a quantum computer running in our laptop. Well, this is not going to happen, at least not anytime soon. Quantum computers are an addition. Like, they're not going to replace classical computers, and they're an addition. And you can rather compare it with a GPU, like which is a specific graphics processing unit, right? Which is specific, well built for a certain task. That's the same thing with a quantum computer, although they are much larger than just a graphics card in your PC and work a little bit differently. quite a lot differently, but you can think about just another acceleration vehicle for specific problems, right? And so typically it's a very specific problem that needs to be identified first. So, and what we do is what we call the reply roadmap to early value with quantum inspired optimization is we go in with the client, we do a workshop, and then we actually select a certain scenario that is well suited, right? That actually benefits from a quantum computer, because like I said, not every problem is of course solvable or well solvable with a quantum computer in a sense that you get actually benefit out of it, right? And then we identify this problem, and then we introduce a certain quantum computing algorithm. It could be QUBO, it could be some other things, like there's also Monte Carlo and a bunch of other basically quantum inspired optimization algorithms that you can use. And it depends on the specific scenario, which is the best one. So we select the scenario, introduce the optimal quantum computing algorithm. And then in the short term, we can run these developed quantum inspired optimization solver on a classical hardware, like a GPU array. And then long term, you can take the exact same algorithm that was developed and put them on a quantum computer. And well, on this one, it will just fly, right? It will be even faster. But that's typically how we approach these projects.
Rene, that was a wealth of information. How can people get in touch with you to learn more about your work?
Yeah, well, you can find me on most social media. For example, LinkedIn, just search for my name, Rene Schulte. Feel free to connect. Also on Twitter, you can find me. My handle is RSCHU. And I keep constantly sharing lots of stuff on social media, so you might want to connect there. And then also my little video series, you can find it called Qbytes, like just like a qubit, but just with another E and S at the end, you know, little byte to eat, so Qbytes. You can find it at the reply.com site. And also if you just search with your favorite search engine, you will probably find it. And yeah, happy to connect. And thanks for these great questions, by the way, Yuval.
Well, thank you very much for joining me today.
Thank you so much for having me. It was a pleasure to be here.